What's going on, guys? In this video I'm going to show you how to add this robot enemy to your game. You can download this entire project in the description of the video for free. I'm also going to post this enemy model separately, so you can just download him if you don't want to download the entire project. Okay, so the first thing you need to do is drag the flying robot enemy into your scene. When you drag him into the scene, it should look like this, and you could just press this little locky button in the top right and just scale him to whatever size you want him to be. I'm just going to make mine like kind of the same scale that I already have in the one that I've already made. Box collider, rigid body, and I'm going to turn my mass up and my drag and the angular drag up a lot. This is just because like when my spell hits my character, because this character is not going to be touching the ground, he's floating. We want to freeze the position on the Y as well so he doesn't fall to the ground. But I'm turning up the mass because when he gets hit, because he's not touching the ground, he'll go flying backwards way faster than the enemies that are actually touching the ground. And by turning up the mass, this will affect how fast he gets like pushed away from the bullet. So then I applied a cartoon material to the character, link in the description. And then I downloaded this quick outline from the Unity Asset Store. I've applied this to pretty much all of my characters and objects in the game. This really adds a lot when your game is like cartoony and stylized. Okay, so now we're going to create this blaster effect. So the first thing you need to do is if you open Blender, if you don't want to open Blender, if you don't have Blender installed, you could just download this model in the description of the video for free. But basically, if you just press Shift A, you can create a UV sphere. You can press 1 to get a side view. If you press Tab on your keyboard, you can press Alt-C to get a see-through view. Just delete the bottom half of the sphere. And then if you press A on your keyboard to select all of the faces, you can press Alt-Z again to get out of X-ray mode. And then you can press Control-T to triangulate this. And then if you press 7 on your keyboard, you can press this little tab at the top called UV editing and just get the top down view like this with 7. And if you right click, or sorry, if you press U, you can click project from view bounds. If you do this, your material that's applied on the object will be applied from the top down perspective. If you don't do this, it will be applied all the way around it. I'm not sure which one I did for this. It might be top down. It might be this way. I really can't remember. So after you're done this, you can export this and you just need the FBX file, like the model for this. This is what is coming out of the thing. So when you press play here, you can see there's like these little half cylinders, and that's how I made like the half cylinder. Okay, so then we need to make a visual effect graph. So if you right click there, you could press create and then you could click visual effect graph. If you don't see this option, if you go to the top under window, you could go to the package manager, and then under the Unity registry, you can just type in visual effect. And one of the options should be the visual effect graph. If it's not installed, you can click install here and install it. And then when you right click, the option should be there. We're just going to rename this to Blaster Tutorial. And then you can go ahead and just drag this into the scene. I'm going to put mine onto my character. I've created 2 bullet spawn spots on the character, and this is where obviously the bullets will spawn. So if you click on these and you go to the transform, this is where the bullet will actually appear. So I'm going to be putting these onto these bullet spawn spots. That way they can be exactly where the bullet is going to appear. So let's just do that for right now. And before we do this, we're just going to actually unpack this so I don't screw up my prefab. So we can just drag this onto here. And then if you click play, you can see that this is placed it in the origin of the level or the scene. So just press 0 on all the position things, and then just change the size to 111. And then it should be playing right in front of the blaster. Okay, and if you click edit on the visual effect graph, you can see like the settings for how this is working. And we just want to change this. So at the very top, it starts with a constant spawn rate. So this is all these particles are spawning over time. So every second, 16 particles are spawning. Instead of having this, we're just going to delete that. And then if you press spacebar, you can do a single burst. We just want 1 particle to be coming out of the end of it per shot that's fired. And then we can click 1 in the count, and then in the capacity, we can also change this to 1. So only 1 particle is spawning, and there's only 1 that can spawn at a time. The velocity, we're just going to be only doing this on the y-axis. So this should be, instead of having a random amount, we just want this to be always the same. So if you click on this set velocity random in the inspector on the right, you can change the random to off. We don't want this to be random. We just want this to be always like shooting. So you can see this is shooting directly upwards. We want to set the angle of this before we set the velocity. So let's just click and set angle. And we just want to drag this above this. And we're going to make this 90 or negative 90 on the x-axis. And it doesn't look like that did it. Let's just try negative 90. Okay, so this is facing the wrong direction. So if you click on the blaster tutorial that we made, change the X rotation to 0. So it shouldn't have a rotation. And then just try this again. So now you can see that it's going backwards. So you could just change this to -5 and it will make it go forwards. Cool. So the next thing we want to do is we're going to change the lifetime. It's also not going to be random. You could just put this to like 1 second. It doesn't need to last very long. It's just like the flash effect of shooting the attack, right? And at the very bottom here, we start off with an output particle quad. We're going to delete this. And if you drag this out, we want to do an output particle URP lit mesh. And the mesh is going to be that half sphere that we just made. So inside of your project, you should be able to find this. I think I made mine in my staff effect tutorial in a previous video. So staff effect tutorial sphere. So this is where my sphere is. Yours will be wherever you put yours. So we're just dragging this half sphere that we made in Blender onto this slot in the mesh. And then when it comes out, it will be that shape. So you can see that it is that shape, but it's very small. Let's just set the size up here to be much larger. So let's just crush this down, move this over, crush it down more. And then we just want to click spacebar in the initialize. We can set the size and we're going to set it to like 2, 1, and just set it to 1, I guess. Okay, and you can see this is in the wrong spot. So we're just going to drag this up and we're going to drag it back a little bit as well. And just if you go to the game view, you should be able to see where it's coming out of. And this is still a little bit too far. So I think it needs to be a little bit higher on the Z axis like this. Yeah, we just want it coming right out of the tip, and we're going to change some of the settings on this. So before we change the settings, we need to create a shader. Now, I'm not going to create this from scratch, but so at the bottom, there is a output particle URP lit mesh, and you can see there's a slot for a shader graph. If you don't have a slot for a shader graph, it means you don't have experimental operators and blocks turned on. So if you go to the edit menu and you click preferences, you can go to visual effects, and near the top, there's an option for experimental operators and blocks. If you turn this on, this will give you the option to use a shader graph. I'm just going to use the shader graph that I've created, and I'm going to open it and show you what it is. So let me, yeah, it's that one. Okay, so this is the shader graph. So let's just go through the graph inspector settings before we go through the nodes. So we've got it set to transparent and additive. We've turned on alpha clipping. And then at the very bottom, there should be an option if you've turned on experimental operators and blocks for supports a VFX graph. If you don't turn this on, then this shader graph will not show inside of the visual effect graph. So like if you click on this box here and you haven't turned that on, then it won't show up. We have two things here. So we have the Fresnel effect, which is kind of like the outside is bright and the inside is dark. It's kind of like a gradient, but not really. And then this is going into a multiplication with the color. So the color will be like that green color that you saw in the video of it, like actually shooting or whatever. And we have the clipping and the alpha. So we've got Voronoi, which is a type of noise, and it's being moved around with the time node. So we're multiplying the time node by 2, which is just the speed of how fast this moves. So if you make this number higher, these will move faster. And this is getting multiplied by an alpha. So the alpha is a number between 0 and 1, and 1 is fully visible and 0 is not visible at all. And the reason we're multiplying the entire thing by this is we want to be able to control the entire visibility of the entire object all at once, but we also want to have certain sections of it dissolved. So when you look at this and we run it, you can see that I don't have a pause option, but you can see that there's like a little holes inside of it, right? So the whole thing is not invisible. I've set the alpha to 1 here, but the whole thing is not invisible. Only some of it is invisible. So the way this works is there's something called the alpha clipping. And the alpha clipping is, in this case, the number between 0 and 1. And let's say you have colors inside of the Voronoi that are not, so 0 is black and 1 is white. Right? So there's gray colors that are surrounding these little black dots. And these gray colors, they could be like between like 0.4 and 0.6. If it's above the alpha clipping threshold, like let's say we make the alpha clipping threshold 0.5. Well, anything that's 0.6, which is a little bit brighter than gray, will show. And anything that's less than 0.5, so a little bit darker than gray, will be invisible. And if you change this over time, then it will dissolve your shader as it's moving, right? So this makes it look really cool. And then we've created these three variables. So there's the color, which we're multiplying by our Fresnel effect and putting that into the base color. And then we have the alpha clipping, which is how much like is going to be clipped. And then we have the actual alpha, which we're going to use to fade the object. So as it's like going, it shoots out and then it disappears completely at the end. It doesn't just like, not just the holes disappear, but the whole thing disappears. So let's go through how we're going to set that up. So right now I've set the color to green just for an example, but this is not actually how we want it to be. So if you right click in the blank space, you can create a time over life node, sorry, age over life node, and you can put this into a gradient. So, and then the gradient can go into the color. So then you can choose. So we don't need to worry about the alpha values at the top because the alpha is only affected because we're using a shader. It's only actually affected by this number down here. This alpha number here is the only thing affecting the alpha. So even if you put this to 0, it will still show. And so at the beginning, we want this to be extremely bright, like 10 intensity. And then at the very end, it can go down to 0. So it will like fade over a lifetime. So you can see like it starts out super bright and then it kind of diminishes over time. We're going to take this same age over lifetime and we're going to put it into a sample curve. And we want the alpha clipping. Actually, let's just do the alpha first. That'll be easier. So let's put this into the alpha. So we're going to be using this to fade this over lifetime. So if you try to set the color over life when you're using a shader, it's not going to do anything. It's not going to work. But if you do it this way, it will. So we want the alpha to start at 1, which is full visibility. And you could just delete this middle vertice and it will start at 1 and we'll go down here. If you click these little things, you can like turn them so that they're more directly straight. This will just make it more linear. It doesn't really, the effect is the same. So you can see that as it goes, it fades away. And we want this to actually not fade away. So maybe we'll just add another key or we'll make the lifetime longer, something like that. So like near the end, or maybe instead it just won't go all the way to 0. It will just go down a lot. This is just going to make it weird. Let's just do that. Okay, and we don't want it to. Oh, it's because the alpha clipping is at 5. So what we're gonna do now is we need another sample curve, and we'll just plug this one into the alpha clipping. So this one is going to be a little bit different. So the clipping should start at 0. So the whole blaster will be visible because the clipping will be at 0, and then as it goes on, it will go to like maybe 5 and it will just stay at 5. So as it's going, like as it shoots, it will deteriorate the entire thing as it's going. Let's see what that looks like. And you can lower this number. Like if you don't want these to be, oh, whoops. If you don't want it to be that deteriorated, you could just lower these numbers so that it stays longer. It will still fade at the end. And I think this is kind of the effect that we have. The other thing you could do is you could set the angle over the lifetime so you could rotate it or something like that. I'm not going to do that just because I don't, this tutorial is going to be too long if I do that, but you could rotate over lifetime would add something to this, I think. Let's just see what this looks like in the game view. So it's this cool little blaster effect. I think it really adds a lot to the way that it looks. So let's go ahead and save both of these things and we'll just dock them up here. Okay, so after you're done with the blaster effect, you do need to create these 2 bullet spawn spots. You can do that just by right-clicking and clicking create. And I probably should have done this earlier when I added the effect or whatever, but you can click create empty and just make a bullet spawn spot for in front of both of the blasters, right? So make sure it's exactly where you want it to be. This is where the bullet is going to spawn. So I have one here and one here, and you need to put a visual effect in each of the bullet spawn spots in the correct spot so that he can shoot, right? So if you click play, it should look like it's coming directly out of it. You should verify this in the game view if you can. I don't Oh, you can't press play from the game view, so that kind of sucks. But if you press play and you pause it and you go to the game view, you can see that this is like directly in front of the thing. The other thing you need to do is we don't want this to start playing right away. So if you click on your visual effect graph and you see on the right where it says initial event name, it will say on play for you. I've already deleted this, but just delete where it says on play. This will make it so that when your graph starts, it won't actually play. And then the other thing you need to do is if you click on your visual effect graph at the bottom, if you look at the top here where it says culling flags, just click on this and click always recompute bounds and simulate. If you don't click this, when your character is off the screen, it won't actually play the visual effect graph, and it acts really weirdly. Like if you move onto the screen, like if you move the camera onto the screen and this is already started, but it wasn't simulating, it will start simulating when it becomes visible, and it's not good. So just because we're working with rooms, we're not working with like an open world or anything like that. This is not a very big area, so you can just leave this as always recompute bounds, and any visual effect graph that you make, you should always just turn this on. Okay, and this is the script that we're actually going to attach to our character. So this is going to be probably the hardest thing of the video. You can download this script for free in the description of the video as well. If you're just following this and using this character for your game or something like that, and you don't want to download the entire project, this is inheriting from the unit class. And the unit class is what we made in the previous videos with the A-star algorithm. Now, we're not using the A-star algorithm for this, so you don't actually technically need the unit class. We're not using anything inside of the unit class, but we are. So the unit class is inheriting from the enemy damage script, and we're using the enemy damage script. When your character gets hit, it flashes white and then it slowly reverts back. We did a whole video on how to do this, so I'm not going to go through it. But if you scroll back through my videos, there's like a picture of like a robot zombie that's flashy all white or whatever. And you could follow that video and you could learn how to make this if you want to. You don't really have to do anything with it. It will just automatically, when it gets hit, it will do that. Let's start with the variables. Okay, so we have the bullet prefab. This is what is going to shoot out. I don't think I showed you this. This will be uploaded in the description of the video. I have a bullet here. So this is the bullet itself. And then I have this bullet prefab where I've dragged this into the scene and I've added just a green material to this. And I added like an emission to it. So the material is just a really, really bright green. And for the yellow variant, it's yellow. And for the red variant, it's red. So that's what the bullet prefab is. Like I said, it'll be in the description of the video. The bullet spawn spots, that's these two spawn spots on the left here. The visual effect graphs, that's what we just spent like the last 20 minutes making. Okay, and then there's a bunch of variables here for stuff that happens down here. Let's get to that later. So in the start method, I'm using the new keyword because this is inheriting from the unit class, and the unit class already has a start method. So if you don't put new here, it will complain at you. If you create a new start method in this script and you have a start method in the unit script or wherever you're inheriting from, you have to call the start method, because it will this is technically just going to start, but this part won't start. So if you don't call base.start, it won't use the start method from the other script. We're just saving the rigid body into a rigid body, and then we're starting this coroutine to do the shooting effect. So this is the coroutine that actually does the shooting. I've got this laser shooting noise from there's like a sound effects website. Okay, so there's a sound effect generating website, sfxr.me, and I think I just clicked laser, and then eventually when I got the sound that I want, you could just download it from here. It's a free sound generator website. So I made this sound generator noise for shooting, and each time it shoots, it actually sets the pitch for my sound effect source to a range between 0.8 and 1.2. That way it doesn't always sound the same when it's shooting. It always sounds different. We're choosing the spawn spot between the bullet spawn 1 and bullet spawn 2. So these are the transforms that we made for where we want it to spawn. This is called the ternary operator. So if this is true, then it does this one. If this is false, then it does this one. So this transform will be one of these two based on if this is true or not. Okay, and then because it's rotating back and forth between the guns, it's shooting every other gun and it goes in order. So after it's done this, it will set the use for spawn, which is this Boolean value, to be the opposite of what it currently is. So if it's true, it'll become false, and if it's false, it will become true. We're instantiating the bullet prefab, which is it's just like a a very basic bullet. It's very easy to make in Blender. You could even use a cylinder if you don't have a bullet. And then we're setting that to be at the chosen spawn, and the rotation is going to be the rotation of the character. So the actual the character, the robot, the flying robot rotation. Then we're adding force because my bullet is in the wrong direction because I exported it in the wrong direction. This should be transformed up forward usually, but I exported it in the wrong direction. So because of that, I had to use negative transform up, so like downwards, and then I'm multiplying it by 150 to make it go very, very fast. And then I'm destroying the bullet after 3 seconds. So there's a chance if it doesn't hit the wall, it will just go flying off into outer space. And we can't have the bullets just sitting there for a long period of time, especially if someone leaves the game running or something like that. So you just destroy the bullet after it shoots. And this is using a player sound effect source I created. So I can't really go into the player class. The player class is just a static class that I have all my variables for my game saved in. So then I have another class called initialize player, where I drag all these variables into their static variable counterparts. And sound effect source, your sound effect source has to be attached to a object inside of the game. So I have an audio player file here that has 2 sound effect sources. One is for the music that's in the background, and one is for sound effects. And this is the one that's for sound effects. And so this play one shot will just play the specific noise, and then it will carry on what it was doing. Like you can just so playing one shot is just like to like play a clip, like especially for sound effects, this is what you use for that. So I think that's it for this. So after it's done playing this coroutine, it will call itself again, and it just waits for 0.5 to 2 seconds, and then it just does the same thing. This plays the actual effect. So the visual effect that we have imported at the top, this plays this. It plays it and it waits 0.1 seconds because it takes a little bit for that little effect to get out of the gun or whatever. So to actually appear and show up, we don't want the bullet to appear immediately. We want it to appear after a short period of time. This could even be a little bit longer than that. It might be better. So that's pretty much it for the shooting coroutine. Okay, so now I'm going to go over the movement. So inside of the update method, this is what's making the enemy move. So let me just open Paint and I'll describe how this is working before I try to show you. So this is the player right here, right? And this is the enemy here. And so there's a couple things that we want to happen. We want the enemy to be moving towards the player and away from the player in an oscillation, kind of like forward and backwards kind of motion. So he'll start by moving closer and then backwards, etc. But we also want this enemy to orbit around the player like this. So that way, like he's moving back and forth around the player as well. So he's more difficult to shoot. He shouldn't just be standing still shooting at the player. That's kind of boring. He also moves up and down slightly. So to do this, let me just move this a little bit over. So we're getting the time elapsed, and then we're getting the oscillation offset. Now this is what's used for the forward and backwards. So this one is the oscillation offset. I'll just write OO here. And we're using the sine. And so there's 2 variables involved in this. There's the frequency, which is how fast it's moving back and forward. And there's the amplitude, which is how far. So the speed is like how fast it's going. And then the amplitude is like how close to the player it's going to get and how far away from the player it's going to get. So sine is just a number between -1 and 1. So let me just start a new document here. So there's 2 things that we're using. We're using the sine and the cosine. So this is a line. So this line is going to represent the time. Okay, so 0 seconds, 1 second, 2, 3, 4, 5, etc., counting up forever, and that's the time elapsed. Sine starts at 0, and at 1 second it goes up to 1, and this is -1 down here. At 2 seconds it goes to 0. At 3 seconds it's at -1. And then you have this kind of pattern where it's like, just ignore my drawing. But anyway, so this is the sine, right? So the time elapsed, which is this field that is getting inputted into cosine, is the time on this graph. So the higher this number is, like the faster this number counts up. So like if your frequency is higher, like let's say this is 2, well, then it's going up by 2 every second. So yeah, so this is the speed at which this happens, and then this is the distance. So the amplitude would be this number when it's at 1. You're multiplying this by the amplitude. So if the amplitude is like 100, this would be 100. And when it's at -1, it would be -100. So this is only good if you want it to move the exact same distance forward towards the player as the distance away from the player. You could do something more complicated, but we're not going to do that in this case because this is already kind of difficult. And then we're using the cosine. The cosine is not the same. The cosine starts at 1 and it actually goes downwards to begin with. So at 0 seconds, it's at 1, and then it goes to at 1 second, it's at 0. At 2 seconds, it's at 1. At 3 seconds, it's at 0. At 4 seconds, it's at 1, etc. And you get this different pattern. So these are completely the opposite, which matters because when we're orbiting, we're using the X and the Z axis. So if you have your enemy here and your player here, and you want to move this way in orbit around the character, well, this is the X axis and this is the Z axis. And you need to do both of these at the same time for it to move in a orbit style motion where it's moving in like a circular pattern, but still it's going to be looking at the player, obviously. But you need to use both of them at the same time because both of these values are changing at the same time in order for the orbit to work. So that's why we're using cosine here. Cosine doesn't really matter here. This could just be sine. We're just the up and the down of this doesn't really matter. It doesn't have to be in synchronization with him moving forward and backwards. So there, if he's moving, so let's say this is the player and we'll do this like vertically, and this is my enemy robot guy, and these are his arms, his blasters, right? If he's moving forward and backward, if you do these with cosine, every time he's forward, it'll be here. So like he'll move upwards, and every time he's backward, it will be here. So we probably should just use sine. I'll just change it after. I'm not going to do it right now. This video is already super long. So this is probably not actually the best way to do this, but for the orbiting, it is required because otherwise it will not orbit the player correctly. So you can't use sine for both values. You have to use cosine for one of the two. It doesn't matter which one. It will still work either way. But yeah, that's how we're making him orbit the player. So then we're getting the direction to the target. This is a very common thing. You just subtract the position of the target from your player's or your enemy's position, or the object's position, I guess in this case, and then we're normalizing it so that it's always the same amount, no matter how far away the target is from the player. And then the target position is having all of these things added together to it, and then we're adding the vertical offset to the Y that we're calculating up here, and then and then we're setting the direction to target Y to 0 because we don't want the player to look up or down. We only want the player to be looking, sorry, not the player. I keep saying player. This is not a player script. This is the enemy script. We don't want the enemy to be looking up or down. We only want him to be looking horizontally. The player, if he falls in a hole in the ground, he'll teleport way above the map and then he falls into it and it pixelates and that kind of stuff, right? Well, if he's above the map, we don't want the enemy to be looking up at the player, shooting things on him while he's falling. And we're also only shooting the projectiles in a direct straight line. They're not being affected by the y-axis. I think we are anyway. I can't remember. Oh no, okay, so it would go shooting, but we don't want that. We don't want, like, if you fall back into the map, we don't want the enemy shooting at you while you're falling, especially while the screen is pixelated. So the direction to target Y is going to be 0. So that way you're shooting, you're looking directly horizontally straight. You're looking towards the player, but only in the y-axis. You're only looking at the player in the x and the z axis. You're not actually looking at the player in the y-axis vertically. So then we're adding -90 to the rotation because I imported the object. And let me just go back to Paint. So this is the enemy, right? And the way he's imported, he's looking downwards. So by adding -90 to the x-axis, he'll be looking straight. It's just because I imported him wrong. That's why we're doing the adjusted rotation. we're slurping. So this is spherical interpolation. So instead of him immediately rotating to the adjusted rotation, he will rotate to the rotation over time. So he's going to be looking towards the target, but he's not immediately going to snap onto the target. He's only going to be rotating the rotation speed per frame. So he can only rotate up to whatever your rotation speed is, like 5 every frame. And then like that way, if your player goes zapping across the screen, he's not going to like immediately rotate towards him. Especially again, if you fall in a hole, he'll teleport above the screen. You don't want him to like immediately like flip all the way around. You should only be able to turn a certain amount per frame, and that's what slurp is used for. It's short for spherical interpolation. It's yeah, it just helps you to slowly rotate. And then we're moving towards the target. Or sorry, we're moving towards the movement thing that we calculated earlier, the target position, which was all of this calculation that happened up here. So we're getting that direction, I guess. And then we're moving towards that direction, multiplied by the move speed. And then we're moving the rotation to this rotation that we calculated. We also are shooting at the player. There's a projectile script that is attached to each one of the bullets. This only really applies if you're using my game. We already covered these things in previous scripts. This is, we had to create a add impact on game objects because we're using a character controller on our player. We're not using a rigid body, so you can't just add force to it. And then this does damage to our player. Again, if you watched the video series and you went through all of the videos, this should be already in your game. If not, if you download the entire project, which is linked in the description of the video, this will be included in that as well. And then we have a sound effect that I think I got from freesound.org. And yeah, it's just a damage noise. So like when it hits the player, it makes a hitting noise. And then we don't want the bullet to be destroyed if it hits a player, but if it hits anything else, it should get destroyed. So sorry, if it hits an enemy, because we could have multiple of these enemies all in the same room, if they shoot a bullet and it goes through one of the other enemies, we don't want it to destroy the bullet. We only want it to destroy the bullet if it hits the player. All right, guys, thank you so much for making it to the end of the video. It really means a lot to me. If you made it to the end of the video, leave a comment down below. I doubt that a lot of people actually made it to like right to the end, but yeah, if you guys have any questions, you could also leave a comment or you can join my Discord down below. And yeah, hopefully I'll see you guys in the next one.